In this class, we will understand 2's complement positive and negative numbers range. So this concept is very important to understand. So we are going to understand this concept, we have to solve 3 questions. So these are the 3 questions that we have to understand. So we will solve these 3 questions. Before that, I have an announcement for you. It is a quiz announcement. So we have created a quiz on this entire section. So section 5. So we have created the complete quiz on this section. So the link for that quiz is provided in the description. So those who are continuously watching our videos, I request you to solve those questions so that you can have better understanding of those concepts. So the link for the quiz is provided in the description. Click on that link. You will be redirected to this C programming course. There you will be provided with the quiz course content, in that all the sections will be available. So just click on those sections, section 5. In that section, you'll be having a link for the quiz. So just click on that and attempt that quiz. And you can learn the same course on our Learning Agent app. There you can learn the complete course. So in the sequence that is provided in the YouTube, everything is available for free. So let's go on to the concept. The first question is, how many unique binary codes are possible with a given number of bits? So what I mean to say is, given, let's assume that we are having 3-bit space. How many unique binary codes are possible? So there are 8 possibilities. So 8 different binary codes are possible with zeros and ones. Okay, so how can we understand this? In this given space, what is the possibility? We can place either a 0 or a 1. And in this space, what are the possibilities we have? You can place either 0 or 1. Simple permutations and combinations problem, right? So in this space, we have either we have a possibility to place either a 0 or a 1. Means, so we have 2 possibilities, and here also 2 and here also 2. So the total number of unique codes that are possible is 2 into 2 into 2. So in short, we can call this as 2 power n. Okay, so for example, if there is a possibility to place 3 codes means 0, 1, 2. If there is a possibility, then it is going to become 3 power n. So but our case is just this one. So we are having only 2 codes, 0 and 1. So which is 2 power n. Now with these 3 bits, how many number of binary codes are possible is, it is 2 power 3. N is the number of bits, 2 power 3, which is equivalent to 8 binary codes. So what are those 8 binary codes? These are all the 8 binary codes that are possible with 3 bits. Okay, so this is the first question that we need to understand. And this question is related to the remaining 3 questions. So let's go on to the second question. So the second question is, what are the range of signed n-bit integers are possible? So given an integer which is a signed integer, so let's assume that int x, by default, if you don't mention any qualifier, it is going to be a signed number. Signed means both the negative and positive numbers are possible for this variable x. Now what are the range of, and let's assume that the number of bits that are possible. So our computer is a 4-bit computer, let's assume, because we don't have any 4-bit computers existing. Or they are not even created. So let's assume that our computer is a 4-bit computer. For understanding, we have taken this as 4 bits. How many range of numbers are possible for this variable x with these 4 bits? And it is a signed number, signed variable. So the range of numbers that are possible are, it is minus 2 power n minus 1 2 plus 2 power n minus 1 minus 1. So what it means is, it is this n is 4 bits. So it is going to be 2 power n minus 1. So the minus numbers range is minus 2 power n minus 1. So 2 power n minus 1. Why we have taken this? So understanding this is very, very important, because so as we are having 4 bits, why we have taken minus 2 power n minus 1 is 1 bit. So in the 4-bit possibilities, we have considered the leftmost bit for sign. And because this is a signed number, the leftmost bit is assigned for sign. Try to understand this. So that is the reason why we have taken 2 power n minus 1. For example, so because this is a 4-bit computer, it is minus 2 power 4 minus 1, which is 2 power 3, means the range of numbers, negative numbers are going to be at most minus 8. So we have discussed it the same in our previous example. And what about the positive side of our number system, which is plus 2 power n minus 1 minus 1, which is going to be 8 minus 1. 2 power n minus 1 is 8 and minus 1 is going to be 7, and this is on the positive side, so it is going to be plus 7. So the range of numbers that are possible for a signed n-bit integer is minus 8 to plus 7. So try to understand this. Minus 8 to plus 7, and the formula for this is the formula. So don't try to remember. I've explained the logic behind this formula also. So why 2 power n minus 1 is the leftmost bit is we are going to assign it for sign, and that is the reason why 4 bits are there. It is 2 power n minus 1. On these 3 bits we are going to get the magnitude. So that is why it is 2 power n minus 1. So that is already explained. Don't remember any formula. Okay, there is a logic behind that. Try to understand that logic. So the range of numbers that are possible for this X, which is a 4-bit computer, is minus 8 to plus 7. So if you try to assign plus 10 to this X, is it possible? No, it is not possible. Because this computer with 4 bits is going to calculate only the calculations on the range of these numbers, minus 8 to plus 7. So try to understand this. And so these concepts we are going to again discuss in multiple different courses in our next semester courses, second, third and fourth semesters. So the third question is, what are the range of unsigned n-bit integers are possible? So what it means is, if a variable X is declared as unsigned int means only positive numbers. What are the range of numbers? Range of positive numbers that are possible. So can you guess that? So it is from 0 to 2 power n minus 1. So how we got that? It is very simple. So previously, let's assume that we will take the same example of 4-bit computer. Now to this 4-bit computer, so the range of positive numbers that are possible for this variable X is, so all the 4 bits are used for magnitude. We are not going to assign this last bit for sign. So in this case, if the variable is assigned as unsigned int, now we have to take all the 4 bits for magnitude. There is no need for us to represent sign. So with this reason, we are going to get a great range of numbers, which is from 0 to, so because this is a positive number representation, it is going to start from 0 and it is going to end till 2 power n minus 1. So which is 2 power 4 minus 1, which is 16 minus 1, the range of numbers. So the possibility is 16, as we have discussed it there. So the possibility is 16 possibilities are possible, and the range of numbers is from 0 to 15. So try to understand that it is from 0 to 15. Okay. So this is all about the range of positive and negative numbers that are possible for the given number of bits. So that's it for this video. See you in the next class with another new section. We are going to go into our next section, which is section 6.